Hi guys, for this video, let's talk about molarity and molality. So, what is molarity and what is molality? First, molarity and molality. They are both measure of concentration. Now, what is concentration? What do you mean by concentration? So, concentration will tell us how much solute is dissolved in a given solvent. Now, what are the differences between molarity and molality? So, molarity, denoted as capital letter M, is defined as the number of moles of solute divided by liters of solution. So it is moles per 1 liter of solution. On the other hand, molality, denoted as small letter m, is defined as the number of moles of solute divided by the kilograms of solvent. So take note that in molarity, the denominator is liters of solution, while in molality, the denominator is kilogram of solvent. So liters of solution implies volume, and when you say solution, it is solute plus solvent. So for example, if you mix sugar with water, it means for molarity, it is the sugar plus water. While in molality, kilograms of solvent implies mass. So it is solvent itself, the mass of solvent itself. So if you mix sugar and water, it is only referring to water. So the kilogram of solvent is only referring to water. So I hope their differences are clear. So let's solve problems for us to better understand these concepts. So let's solve this problem. This is from EA Board April 2003. Hydrogen peroxide solution for hair bleaching is usually prepared mixing 5 grams of hydrogen peroxide, H2O2. Molecular weight is equal to 34 grams per mole per 1000 ml of solution. What is the molarity of this solution? So for this problem, luckily, the molecular weight is already given. However, if the molecular weight is not given, so you need to compute for its molecular weight using the given molecular formula, H2O2. So you need to at least memorize the atomic weight of the basic elements like hydrogen and oxygen. So since the molarity is defined as the moles of solute divided by the liters of solution. Then first, let's find the number of moles. So the number of moles, N, is equal to the mass divided by the molecular weight. So the given mass is 5 grams divided by the molecular weight, 34 grams per mole. So as you can see, the grams will cancel out, leaving us with the unit moles. So we can now calculate for the molarity. So molarity is equal to 5 over 34 moles divided by the liters of solution. Since the given is 100 ml, then we'll convert it into liters. So 100 ml times 1 liter is equal to 1000 ml. So now we can now solve for the molarity. This is 5 over 34 all over 100 over 1000. So this is equal to 1.47058 and so on moles per liter. So in the choices, the nearest to this 1.47 is 1.5 m, 1.5 moles per liter. So the answer for this problem is letter B, 1.5 moles per liter. So take note the unit of molarity, moles per liter or just M. Now let's solve another problem. For the second problem, what is the molality of the solution that contains 65 grams of sucrose C12H22O11 dissolved in 300 grams of water? So as we learned moments ago, the molarity is defined as the number of moles of solute divided by the kilograms of solvent. So first, we need to get the moles of solute. However, the molecular weight of sucrose is not given. So we need to calculate for the molecular weight of sucrose. So the molecular weight of sucrose is equal to the sum of the atomic weights of the elements involved. So the atomic weights of carbon is 12. However, there are 12 carbon atoms, so times 12. The atomic weight of hydrogen is 1. However, there are 22 atoms of hydrogen, so times 22. And there are the atomic weight of oxygen is 16. However, there are 11 atoms for oxygen, so multiply by 11. So the molecular weight of sucrose is equal to 12 times 12 plus 1 times 22 plus 16 times 11. So this is equal to 342 grams per mole. Now, we are now able to to calculate for the moles of solute. So number of moles of solute is equal to the mass divided by the molecular weight. So this is equal to 65 over 342. So now we are all set to compute for the molality of the solution. So the molality is equal to moles of solute, 65 over 342, all over the kilogram of solvent. So take note, the given is 300 grams. So let's convert this to kilogram. Times 1 kilogram is equal to 1,000 grams. So this is equal to 65 and 42. So this is equal to 0.6335 and so on. Moles per kilogram. So in the choices, as you can see, this is approximately equal to 0.63. So the answer for this problem is letter D, 0.63 mole per kilogram. So take note for the unit of the molality, it's moles per kilogram. While the molarity, the unit is moles per liter. So they are also different in units. So that's it for this topic. Thank you for watching. I hope you learned something and God bless.